Hi, this is a video from Zimmer Peacock about cloud-based process control and really is part of Internet of Things. But at Zimmer Peacock we have a unique technology called Djuli. Djuli is a cloud database that can receive, process, store, analyze data. So what Djuli can do is, at Zimmer Peacock we're very well known for our biosensors. So Djuli can receive data from biosensors, but I will expand this conversation to say that Djuli can receive data from lots of types of sensors and then take action upon that. So for example, with the biosensors we have glucose sensors, we have lactate sensors, we have oxygen sensors, we have pH sensors, redox sensors and conductivity sensors, but we actually have over another 24 types of sensors as well. So for example, these sensors are very useful in the sort of bioprocessing realm where people want to control pH or no pH and control glucose, etc., and dissolved oxygen. So at ZP we have both the Djuli database that can, it's a cloud database system, can receive sensor data, and also we have the front end of all of this, which is the biosensors themselves, and of course the electronics to go between the two. But Djuli can also receive other types of data, so it can receive, or she can receive temperature data, for example, humidity data, pressure data, flow data, electrical parameters like voltage and current, and also of course it can calculate things like charge, knowing these kind of things, light sensors, cameras or images, and etc. And the reason I put etc.s there is because Djuli is a database. In the end, it doesn't mind what the data is, as long as there's sort of information or a string of numbers, there's an image, etc. It doesn't mind what the data type is. It can be video, it can be audio, it can be visual, it can be a string of numbers, etc. So we also then have Djuli that can receive these kind of condition type sensors. And then the next part of this is that Djuli can also, because it's a cloud system, can also receive kind of unique sorts of data which are not necessarily scientific and commercial. For example, it can receive market data. What is the value of a particular product at any one time? It can receive market information. For example, what's the cost of a commodity such as gas or electricity? So whether you want to run a process is in part could be driven by market forces. What can I sell my product for, and what's my cost of my incoming commodities, like, as I say, gas and electric. Djuli can also run on accordance to time, so you can have timed actions. Djuli can also receive, for example, weather data. So whether you run a refrigeration unit or not, you could be predictive of that based on on what the temperature is actually going to be. It can also just be on calendar, so you can have a process that sort of periodically comes up and based on a calendar process. So these are not biosensors, they're not conditional sensors, but there are other types of inputs that Djuli can take action upon. Also, for example, market trends. For example, the price of copper is going up and you have a electroplating technique, you can adjust your ability to use or process copper based on the copper prices, for example. So Djuli can also take care of that. So Djuli really can take care of or can deal with rather inputs that we would call a sort of API, an application programming interface. So Djuli also has that capability. So far we said that Djuli can at least pull on three sources of sensor data: the biosensor data that Zimmer Peacock has all these sort of biosensors for, conditional sensing, things like temperature, humidity, pressure. Also then API type of data, market trends, weather forecasts, actual weather, commercial considerations. And then having received these inputs, Djuli can then take action, and this could be commanding a refrigeration unit to come on, turning a pump on or off, telling a battery to store or to discharge, or telling an electrolyzer to turn on or to turn off, turning fans on and off, for example, sending alerts. I mean, shown it by email here, but alerts are not restricted to just emails, let's say. But again, we can also send out information via an API as well, an application program interface. So Djuli sits at the heart of this, and essentially what we have are inputs, and Djuli can analyze those inputs and then send out outputs, which can be commands telling other systems what to do. But also then these other systems can provide feedback, and Djuli can modify its output based on a feedback loop. So let's have a high level view of a simple in, simple out sort of feedback loop. So for example, it's certainly not hard to have humidity and temperature in a sensing location. So if we want to control on humidity and temperature, we can have one of our base stations at the location. The base station can send data to the Djuli. Now Djuli has been told by the user control, for example, the temperature and humidity at these set points. I'll focus on temperature to make this simple. So control the temperature at this set point. Now Djuli will look at the temperature, see what the difference between the set point temperature is and the actual temperature is, and it can take an action to send a command back to the base station to turn on an effector, which in this case is a fan. Now the fan, I can see, because I haven't indicated refrigeration, I know the limitations of this control, but the fan comes on and provides a change in the temperature. So it could cool it or heat it depending on set points and depending on the mechanics of that fan. But at this point now, we actually have a control loop where temperature is our input. It goes to Djuli. Djuli analyzes the temperature versus a set point, and then Djuli sends a command back to the effector, which is the fan in this case, and the fan can come on or come off depending on that. Now this is simple in, simple out, or sorry, signal in, signal out. This is a sort of simple system. You could also have other considerations like what is the cost of turning that fan on. And again, I mean, with a modern cloud database like Djuli, you can bring in the cost of electricity as part of the equation here. I'm going to do something more complicated now, which is multiple inputs and multiple outputs. So again, we have Djuli. It resides in the cloud, and because it resides in the cloud, it can bring in data again. What's the cost of gas or power or electric at this point? What's the value of the output of my process? And what Djuli can do is run a differential control and say, when the difference between my output has 4 times the value of my inputs, then I'll run my process. So Djuli sends a command to the base station. In this case, it's setting it to a electrochemical cell. Now, this electrochemical cell could be a battery. It could also be an electrolyzer. So in this case, I'll show it as an electrolyzer. So when the price of a chemical is, for example, 4 times the cost of the gas to run the process, then the electrolyzer can be told to turn on, and it can make, for example, a chemical. But because we're talking about multiple outputs, we could also run that process slightly harder and basically come out with another chemical. But the chemical that you come out with is based on the market value at the time and the energy cost to produce each of these chemicals. And you're sort of balancing to get the greatest margin. And so you can run the process based on your inputs and then actually control the output based on that output that gives you the best, let's say, margin at the time. So what I'll do is I'll summarize this, that Djuli is a cloud database. It can receive data from multiple inputs. This could be sensor data, like biosensor data, glucose, lactate, oxygen, pH, dissolved oxygen, redox, for example. It can also receive data from condition sensors like temperature, humidity, pressure, flow, voltage, current, light, for example. And Djuli can also receive then inputs from other systems via API, application program interface. So it can receive market data, weather data. You can also look at future trending data, for example. And then it can create outputs, which it can then affect real world devices such as pumps and fans, electrolyzers, batteries, etc. And it can actually sort of balance multiple inputs and to almost determine outputs based on which inputs relative to the outputs, or which output should it be generating relative to the inputs. So it can essentially make some commercial decisions as well. So if you have any questions about Djuli, please don't hesitate to reach out to us at Zimmer Peacock. Okay, thanks very much.